All right, let's start with a very important numerical from numerical number 10-36 and 10-37, basically combination of two different numericals. Okay, so we will basically solve with two numericals here simultaneously. Find what does the numerical says? Find the centroid y bar of the composite area shown and calculate the second moment of area, but he is telling you how many second you will calculate the second area. You need to calculate about the ix dash and iy. Okay, you need to calculate the second moment of area about now what is he's trying to say over here, about which axis? This is the axis he's telling you. Second moment of area of the entire basically composite area here, ix dash, about this. And he says also calculate the second moment of area about the y-axis, about the y-axis. So and basically this is, you have to calculate two second moment of areas, one for ix dash and iy. That is what he's trying to say. So basically this is very important. Now apart from that, here you can see this is all a rectangular shaded area. Okay, the second, this area, composite area, is all rectangular. Okay, so just to give you further know-how, if you look at this picture, moment of inertia of a rectangle. Okay, I have derived it over here completely. If you want to you can do it yourself. That moment when we take a horizontal strip, this is one rectangular whose height is h by 2 and h by 2 from the centroid. Total height is h and its width is b. Okay, this is x-axis, this is y-axis, and you know that basically from the centroid the height is y tilde. Okay, and this y tilde is equal to y. He's basically explaining it to you over here. So if you take a horizontal strip to calculate ix, okay, if you take a horizontal strip to basically calculate ix, here we have taken this is the strip width b and this is the height dy. Okay, we have taken the horizontal strip. So when we calculate it, ix, okay, is comes out to be equals to bh cube over 12. Remember, bh cube over 12, which means the rectangle base is b and the height is h. b h cube over 12. Okay, this is the derivation. You can do it. It's very simple. Area they have given it to you as d dot dy. Length of the area of triangle is length into width. Okay, so when you calculate it, your ix comes out to be equals to bh cube over 12. Now if we take a vertical strip in order to calculate iy, if we take a vertical strip in order to calculate iy, so we have taken a vertical strip. It will be basically the so it will be basically the area will comes out the second order h dx. Okay, the height of the strip will be h and the width of the strip is dx, and you put it in the integral of x tilde square times dA, you will put it, and you will get iy as hb cube over 12. Okay, so very important conclusion over here you have to make, that the moment of inertia of a rectangle when we take about the x-axis, ix, the moment of inertia, second moment of area about the x-axis, and that is ix is going to be bh cube over 12, and when we take second moment of area of the rectangle about the y-axis, it gets basically opposite of that, so it becomes h b cube over 12. For ix it is b h cube over 12, and for iy it becomes the opposite, basically it becomes h b cube over 12. So this is a very important conclusion for rectangles. You must take it. In the previous problem when we were basically doing the parallaxis theorem, okay, we used basically for the iy we used the hb cube over 12. Okay, this formula, okay, for the rectangle. So you must remember this very important conclusion over here. Now he says that in order to solve it, the given composite area, there are some important conclusions that you must make here. Is he says that the given composite area after seeing this picture is completely symmetric about the y-axis. This is very important point. It's symmetric about the y-axis, but is not symmetric about the x-dash axis. You can see if you cut it along the x-dash axis, the masses will be different on both sides. But if you cut it along the y-axis, it is totally symmetric, mirror image of each other. Second very important point, when a composite area volume is not symmetric about a given axis, its second moment of area is always calculated using the parallel axis theorem about that axis. Okay, what is when a composite area and volume is not symmetric, where it is this way. So whenever we will calculate Ix dash over for this area, we will be using the parallel axis theorem. The second moment of area about the symmetric axis can be calculated using Boolean algebra. Okay, simple Boolean algebra for simple shapes. If and only if the centroid of all simple shapes lies on that axis. This is a very important point we will discuss before calculating Iy, but you must know. So these initially concentrate on these 2 points. So the same, we have basically broken up this shaded area into 3 segments. Okay, our segment number 1 basically will be comprising upon, if you look at it, it will be comprising from here to this is our segment number 1. Remember, okay, this is our whole segment number 1, and this is 2 and this is 3. Okay, so this is 2 and this is 3. You must remember them. Okay, so this is our segment. If you look at it, this is going to be 1, this is going to be 3, segment 3, and this is 2. You must remember this. Okay, so and this 1 is very important. Don't get confused. This whole rectangle is 1. So if you look at this is the picture 1, 2, 3. This is our x dash axis from the centroid. Our first prime target is basically in the question given as to calculate y bar, centroidal coordinate y bar from the centroid. From where? From this point to this point. This is the most important our target is. So this is basically our x dash axis, this is y. So now the picture is clear, the dimensions, and very important point that our origin point will be, this is going to be our origin. This is our origin. This is our origin. All the calculations will be done from this origin. Very important point, remember. Okay. So now what we do is segment 1, I have already explained you what will be the area for the segment 1. 3 plus 3 rectangle, 3 plus 3 6, and what is the height to this point? You go from here, is the height is basically from here to here, the height is given as 2. So the area of the rectangle is 2 into 6 equals to 12 inches, 12 inch square area. Okay, since we are basically calculating y bar, so we have to calculate the centroid of this rectangle which is on the y-axis. So the total height given is 2 inches. The centroid of this rectangle in the y-axis from this point will be 2 divided by the half of 2. Okay, if you divide 2 by 2, it will get as 1 inches. Now you go to segment 2, which is this rectangle. This rectangle area is basically from here, if you look, they have given us this is 5 inches, this is 2 inches. So this length will basically be how much? Very simple, it will be 3 inches. So it will be 3 multiplied by the width is 1. So the area of segment 2 comes as 3. What will be the centroid? Now this is a very important point. What will be the centroid? Okay, this is the centroid of this approximately of this rectangle. Okay, so we have to calculate, but we have to calculate the centroid from the origin. We have to calculate it from the origin. So basically from the origin, if we start basically, so the total height from here to here is 2 inches, and this height in y-axis is how much? 3 inches. So half of 3 inches will be 1.5 plus this height from the origin is 2. So we write it as 1.5 plus 2, it comes out to be equal to 3.5 inches. Same for the for this one also, this will be the centroid, and you can say the centroid of this rectangle will be, I can easily deduce it as somewhere 1 inches. Say this is the 1 inches. Okay. So these three green points, if you look at it, these 3 green points, this is the centroid of 3, this is the centroid of 2, and this is the centroid of the rectangle, this green point. And what about this one? If you look at it, what about this red one? This is also a centroid. If you look at it, this is also a this is a centroid also, but this red centroid is the centroid of the entire segment or entire 3 shapes 1, 2, 3. Okay, so you must remember that this is our shape 2. This is our shape 2. This is our shape 2, 3, and this is our it's written this is our shape 1. Okay, so this you must remember, very important point. Now simple, if you say this is the area, this is the y tilde, so what you will do, you will basically multiply. Why you are doing all this? Because you need to calculate the y bar. So y bar is equals to same formula, summation of y tilde into a summation of divided by summation of all the areas. So again, y tilde into a for segment 1 is 12, y tilde into a for segment 2 is 10.5, and mirror image for segment 3 is also 10.5. You all add all the y tildes. What you do, you basically add all the y tildes to get 32.7, and then you add all the summations of the areas. So you divide y tilde a divided by summation of all the areas, you will get this answer. Y bar of the entire 3D of the shaded area, 2-dimensional shaded area is 1.816, and this is what he has given to you. This is y bar, what you calculated. Okay, this is y bar. So now this is done. We have done just a part of it, but remember, again, very important thing, these points are very important. This point 3, which is the centroid of this point, and this green point, and this red point, these points you must remember. Again repeating, this point is the centroid of the rectangle 1, this point is the centroid of the rectangle 3, this point is the centroid of the rectangle 2, and you know what are the values of these points. So let's proceed further. Now again we are calculating, what we are going to calculate, Ix dash. The given cross section is not symmetric about the x dash axis, so the centroids of the elements 1, 2 and 3 does not lie on the x dash axis. Okay, so what you will be doing to calculate Ix dash, we will be using the parallel axis theorem. Okay, why you will be using it? The answer is lying over here, because the cross sections are not symmetric about the x dash axis, and all their centroids are also lying not on the x dash axis. So you can see all the centroids, this centroid, this centroid and this centroid, they are not lying on the x dash axis, so we are forced to take and use the parallel axis theorem. So now what is the parallel axis theorem? It is again very simple. Ix dash is equals to the second moment of area, Ix dash is equals to the second moment of area at the centroid of the segment 1 plus area into d square. So what is he saying now? He says Ix dash for 1 for segment 1, the second moment of area about Ix dash 1 for segment 1 will be equals to I1 plus area 1 into d1 square. Okay, so first of all you need to calculate d1. d1 is what? 1.816 minus 1. This is you are going to calculate first. d1 if you calculate and you put all the values in this equation, you will be putting all the values where? In this equation. Okay, in this equation. So you can say this is your main equation 1. Okay, you're putting all this. So d1 is, what does this mean? If you look at it, it means that from here to here. What is the distance from here to the red dot C? Y bar is how much? 1.816. And from the origin to this first green point, the distance you calculated was how much? It was how much? It was 1. So 1.816 minus this distance. So you will be calculating what distance you will calculate. If you look at it, you will be calculating the height along this and this. Basically, you will be calculating this distance between these two lines. Okay. So 1.86 minus 1, you will be, so what this D is basically, it is the perpendicular distance between the Ix dash axis and basically the distance I1 axis, about the centroid of the rectangle, about this axis. If you look at it, this axis and this axis, perpendicular distance between them. So if you look at this, so it comes out to be 1.816 minus 8. Okay, so this is, so D1 is there. So what is going to be the second moment of area about which point? What will be the second moment of area of this rectangle about if you look at it about this point, and this is, again, just to remind you, what will be the second moment of this whole rectangle about, because this is the centroid of the rectangle, this is the centroid of the whole system. So what will be the second moment of area of this rectangle about this point? So we already know the formula. I have told you it will be because you are calculating about x-axis, it will be 1 by it's the x-axis, so 1 by 12 into what is the height? It is 2 cube, and what is the width of this rectangle? 6. So 1 by 12, 2 cube multiplied by 6. So it becomes as this is your I dash about the centroid of the rectangle. Okay. So and this is about this axis, the horizontal axis, just below the centroid of the whole system. Now once all these values are there, you can just put it very easily. You can just put it very easily over here. So Ix dash 1 of the rectangle about the centroid of the whole system will be equals to 1 by 12, 2 cube into 6. This is the centroid about the green point. This is the centroid. Again, don't confuse. This is centroid about. This is the centroid at the green point. Okay, and this is the at the centroidal green point. This is the moment of area of the rectangle. So this is the centroid of the rectangle, the one, and this and it is the second moment of area line at this centroidal point, which you have calculated it here. So 1 by 12, 2 cube into 6 plus what is the other point? Area. Area will be 3 plus 3 is 6 multiplied by 2 is 12. And what was D1? What was D1? D1 was 0.816. You put it over here. This is square. So Ix dash 1 for the rectangle comes out to be 11.99 inch 4. Again, this is the Ix dash 1 which is acting along this main centroid for this rectangle. But there will be two more rectangles whose you need to calculate and add it as a total in order to get the total Ix dash. So for the second rectangle, if you choose it, if you choose the second rectangle, okay, and for this is our 2. So what is there? Ix dash 2 is equals to I2 plus A2 into D2 square. So again, this I2, second moment of area about the centroid of this rectangle, about the centroid. This is the axis which is passing about the centroid of this rectangle. So again telling you, if you go here, this is second moment of area. This is the centroid, and this is the going to be your what? This is your I bar 1. Okay. From here, this is the sorry, this is going to be I2. This is going to be, I'm sorry, this is going to be this is going to be I2. This is going to I1 is for the rectangle, so this is going to be I2. This axis is going to be I2. Okay. So what we do here, Ix bar 2 is equals to I2 plus A2 into D2 the whole square. So very important, D2. How to calculate this D2? Again the same logic will be there. Basically, if you look at it, the total height from here to the origin is how much you calculated? 3.5 minus what was the centroidal coordinate height along y-axis? It was 1.816. So we want actually the distance from this point, perpendicular distance along this axis from this point to this point. So what it will be? It will be basically 3.5 minus 1.816. So what is he saying? 3.5 minus 1.816. So it comes out to be 1.684 inch. So for the rectangle, it is again 1 by 12. If you look at it from this rectangle, it will be 1 by 12 times, because it is along the, it is Ix2. Here it is written as I2 bar. So again it will be 1 by 12, 3 the whole cube multiplied by 1. Okay, so this is again the formula that you have to learn. I have shown you in the notes, just started in the first initial lecture. So you put this, calculate this, put this value for I1 here, and plus what will be the area? 3 into 1. So 3 into 1, the area will be 3 into 1 is 3, and what was D2? 1.684. What is this? So simplify it, you will get this value. And for again, if you want to, for this rectangle, the rectangle number 3, for this rectangle number 3, it will be exactly the same. Here it is saying for Ix dash 3, it will be, because it's a mirror image, 10.557 inch 4. So finally, for all the entire areas for Ix dash, you will add it. You will add the Ix dash 1, you will add Ix dash 2, and you will add Ix dash 3, because it will, all those three segments combined, these three area segments combined will give you the total second moment of area Ix dash. Okay, step by step by using parallaxis theorem. So now you need to calculate Iy. So for Iy, it is since it is symmetric about the y-axis, the shaded area is symmetric about the y-axis, we can notice that in case of Iy, the given cross section is symmetric about the y-axis, and also the centroid of the individual elements lies on the y-axis. How they say? What we will say, that we will consider the whole rectangle as one solid. We will consider the whole rectangle. If you look at it here, we will consider this whole rectangle as one solid rectangle. We will assume this is whole one. Okay, and from here we will, what we will do, we will minus this rectangle. Now these two have one thing common, is that, what is the thing which is common here? The common thing is there, they both are symmetric about the y-axis. So since they are symmetric about the y-axis, we can use the rectangle formula directly to solve the problem. Yeah. Okay, so this is a very important point that you must remember. What is he trying to tell you? Okay, so we can notice that in case of Iy, the given cross section is symmetric about the y-axis, and also the centroid of the individual element lie on the y-axis. Therefore for Iy, Boolean algebra can be used. So again, for the whole rectangular Boolean algebra, it will be for the whole rectangular Iy, it will be 1 by 12. Okay, and what is the vertical height? The vertical height of the rectangle is 5, and what is the basically depth? Because you can put in Iy, 1 by 12 into 5 multiplied by 6 cube. So Iy1 comes out to be equals to 90 inch 4. Okay. Now for the rectangle, that the inner rectangle 2, what will be the second moment of area? So Iy2 will be equals to, this is 1 by 12. Again, if you look at it, the total height of this rectangle was basically from here to here it was 5, and if you minus 2 from it, you will get 3. And what is going to be the total width of the rectangle was 6, the thicknesses was 1 and 1 minus, so 6 minus 2 will give you 4. So 1 by 12, 4 cube into 3, so you will get IY2 as 16 inch 4. But again, since we have assumed that the whole rectangle was solid and we subtracted it from this shape, so we can say the total second moment of area about the y-axis IY will be equals to the total second moment of area calculated as I1 90 minus the assumed shape that we have assumed it. You can subtract it from this IY2, but we calculated 16. You will get IY equals to 74 inch 4. Okay, so what is this? This actually IY from here. This is IY of this whole shape will be 74 inch 4. This we assumed it as from in the case 1 was whole solid and subtracted it this from it. So it is the same thing we assumed and then we subtracted it to make it balance. Okay, so we can ask you in the exam which second moment of area is more important from the symmetric point of view. The given cross section has higher second moment of area about the y-axis. It means that it is more difficult to bend the given cross section about the y-axis. So what does it means? That when we calculated the second moment of area about this Ix dash axis, it's only 33, which means it can bend easily because the second moment of area is less, bending will be more, and the second moment of area here is higher the second moment of area, lesser will be the bending. So we will, in design considerations, we will be taking IY because there will be less bending. Okay, so I hope this was a very long numerical and very conceptual. You would have understand it better. Okay, thank you very much.